I'd like to do two more examples in this video of finding the radius of convergence of a power series. This is an important idea, and in fact, it's the primary reason that we considered all of those tests for convergence to begin with. So, let's remind ourselves, a power series is a function of this form. The center of the power series is this a value. The interval of convergence, that's just the values of x that you can plug into this function. It's the domain of the function. The radius of convergence is half the length of the interval. The center will always be right in the middle of the interval of convergence. So if you tell me the radius of convergence, then I could deduce what the interval of convergence is as well. So let's do an example. Let's find the radius of convergence r for the function, how about the power series, the sum going from 0 to infinity, minus 1 to the n, x to the 2n plus 1 power over 2n plus 1 factorial. We've actually seen this function before in the class. This is the Taylor series for sine x at x equals 0. But let's find the radius of convergence. So here's my answer. Now the go-to move when asked to find the radius of convergence is to try the ratio test. That's always the first thing to try on these problems. So let's do the ratio test. To do the ratio test, I look at a limit L. So I'm going to look at the limit as n goes to infinity of the an plus 1 term over the an term. So what is that here? It's the limit as n goes to infinity. The n plus 1 term would be minus 1 to the n plus 1, x to the 2, n plus 1 plus 1, divided by 2, n plus 1 plus 1 factorial, divided by the nth term. See, notice though, to get the n plus 1 term, I just took every n I saw here and replaced it with n plus 1. Now, warning, I've seen students do it incorrectly in the past. In my past teaching this course, I've seen some students write the power of x as 2n plus 2. That's not quite right. You need parentheses around the n. Anyway, the nth term is minus 1 to the n, x to the 2n plus 1 over 2n plus 1 factorial. Okay, that's kind of messy, so let me simplify a bunch. So that's the limit as n goes to infinity. I have absolute values. Since I have absolute values, these plus or minus signs I could completely ignore. I'm taking the absolute value anyway. I'm making everything positive. So I'm just going to ignore all the plus or minus signs. Now the powers of x. The powers of x. This power is x to the 2n plus 3. And I'm dividing x to the 2n plus 3 by x to the 2n plus 1. I think all I'll be left with is x to the 2. Then I believe I'm going to get 2n plus 1 factorial divided by 2n plus 3 factorial. Okay, so how do the factorials simplify? I like writing all the factorials out. So on top, I have 1 times 2 times 3 until I get to 2n plus 1. That's 2n plus 1 factorial. And on the bottom, I'm going to get 1 times 2 times 3. I'm going to get up to 2n plus 1 times 2n plus 2 times 2n plus 3. That's 2n plus 3 factorial. It's all the numbers multiplied until I get to 2n plus 3. So this top factorial will cancel with everything except the last 2 terms on the bottom. Now, n is changing, x is not. X is a fixed number. Think of x as 50 or something. So that's not changing, but the value of n is getting bigger. So this has limit 0. I have a constant on top, and I'm dividing by larger and larger values of the bottom. So limit equals 0. Now, if you're new to math, you might not know this, but I'm pretty sure that 0 is less than 1. What that means is the limit L in the ratio test is always less than 1, no matter what value of x you plug in. So every value of x you plug in will give you a limit 0. What this means is the interval of convergence is all numbers. The interval from negative infinity to infinity. It's all possible numbers. On the number line, there's 0, 1, 2, negative 1. Every number is in the interval of convergence for this series. Okay, what that means is the radius of convergence is infinity. It's infinitely big. When you get radius of convergence infinity, what that means is every value of x you can plug in to get a convergent series. What the amazing thing about this problem says is because earlier in the course we saw this is our Taylor series for sine x, this says that the function sine x equals this power series, the sum going from 0 to infinity, negative 1 to the n, x to the 2n plus 1 over 2n plus 1 factorial. This is true for all values of x. Because the radius of convergence is infinity, this always is a true identity. Okay, I'd like to do another example of finding the radius of convergence. So let's do one more example to finish up this video. So let's find the radius of convergence How about for the function, the sum going from 0 to infinity? Let's do n factorial x minus 4 to the n. So this is a power series centered at x equals 4. So I'm going to use the ratio test again. That's the best thing to try when you're doing a radius of convergence problem. So I'm going to look at the limit as n goes to infinity. I'm going to write down the n plus 1 term. So I get n plus 1 factorial, x minus 4 to the n plus 1 power. And I'm going to divide by the nth term, so n factorial, over x minus 4 to the n. Okay, that's the limit as n goes to infinity. I'm going to get n, so n factorial, n plus 1 factorial over n factorial. That simplifies to n plus 1 times the absolute value of x minus 4. Now, x is a constant. The thing that's changing in the limit is n. So as n increases, I get n times something. Okay, now this is almost always infinity. In fact, this is infinity if x is not equal to 4. Because if x is any number other than 4, this is a positive quantity, and then you have the limit of a positive number times n plus 1. That's infinity. The only possible case when this thing converges is if x happens to equal 4. In that case, it's just 0. It's just 0. So the interval of convergence is just x equals 4. That's it. It's a single number on the number line. There's 0, there's 4. That's the entirety of the interval of convergence. It has length 0, right? It's just one number. So in this case, the radius of convergence is r equals 0. 0. Only 0, only the center gives a convergence series. So when the radius of convergence is 0, that means only the center will work as a convergence series. Okay, get some practice with the homework.